Hello Math 1093. In this video we're going to talk about what the sine and cosine functions mean when the circle isn't a unit circle. So what do sine and cosine mean when we're not dealing with a unit circle? That's the big question for this video. You'll notice here I've put up a circle centered at the origin, but whose radius is 3. And that'll be what we use for this video. Alright, so I want to pose the following problem. Suppose I draw an angle inside of this circle, standard position, so it starts at the positive x-axis. And then let's say the measure of this angle is about 2.5 radians. I'm going to guess that's about here. Alright, so it's an angle of measure 2.5 radians. Okay, the question I want to ask is, what are the coordinates of this point? Let's call that point P. What are the coordinates of point P? That'll be the question. What are the coordinates of point P? So to answer this question, we're going to use trigonometry. That is, we're going to use the sine and cosine functions we defined in one of the previous videos in a non-straightforward way. Because we know exactly what sine and cosine mean, what sine of t and cosine of t mean for the unit circle. We know what these mean about the unit circle. And there's no reason I couldn't just go ahead and put a unit circle in this picture, so that's exactly what I'm going to do. I'm going to put a circle centered at the origin of radius 1, so that I can use what we know from our previous work about the sine and cosine. Okay, so what do we know? We'll take a look at this point here, where this ray, the ray to point P, intersects this circle. Let's call that point Q. We know by our definitions of sine and cosine that the coordinates of Q are going to be the cosine of 2.5 radians and the sine of 2.5 radians. Now you notice I'm not writing radians every time I say this. Just assume that anytime I put cosine or sine of something and there's not a degree symbol on it, then I mean radians. Okay, so the coordinates of Q are cosine of 2.5 and sine of 2.5, and I could go ahead and use my calculator to figure out what those are. The cosine of 2.5 radians is approximately, let's see, negative 0.80, so I'll write that down. That's negative 0.80, which seems about right. That looks like it's around negative 0.80. And then the sine of 2.5 radians, according to my calculator, is about 0.60. Okay, so that point Q is approximately negative 0.8, positive 0.6. Now, if I want to know what the coordinates of point P are, well, the main thing to understand about point P is 3 times as far away from the origin as Q. Now, why is that? That's because if I look at this ray, the ray from the origin to point Q, that's 1 unit long. If I go along that same ray, I'll get to point P. I just have to go 3 times as far because the radius of that outer circle is 3. So that means that if point Q is negative 0.8, positive 0.6, then the coordinates of P, those are going to be approximately 3 times negative 0.80 and then 3 times 0.60. That comes out to about, and I'm guesstimating here because there was some rounding that I did, but I think that's going to be about negative 2.40, 1.80. Let's mark that in the picture. That's about negative 2.4 and then positive 1.8. Now you notice that is actually a little bit off according to my picture. That's because I drew that angle of 2.5 radians imprecisely. So any amount that I'm off here, this is actually according to the calculator here. And if I'm off, it's because the drawing of 2.5 radians is imprecise. Anyway, even still, it doesn't look that bad. It's just I'm a little fraction of a radian off. Anyway, the other thing I want to mention about this is I want us to be able to think about this algebraically too. So what did I do here? I said that was 3 times whatever the cosine of 2.5 was, and then 3 times whatever the sine of 2.5 was. Those were the coordinates of my point. So I'm going to write those over here as well. This was 3 cosine 2.5, and then 3 sine 2.5. So what does all this mean in general? I'm going to draw another picture here to illustrate what this means in general. So what this means is, if I have some circle in the coordinate plane centered at the origin, and its radius is r, okay, this is a very cartoonish, Simpsons-ish looking circle there, but you probably get the idea. Okay, and let's say I have some angle whose measure is, let's call it theta radians, and let's say the radius of the circle is r. And I want to know what the coordinates of this point are going to be. Well, the coordinates of that point are always going to be r times the cosine of theta, r times the sine of theta. And that is because I can think of that point as the dilation of a corresponding point on the unit circle. So this point here is going to be cosine of theta, sine of theta. And then this point here is going to be r times as far away. So its coordinates are going to be r times the coordinates of this point. So r times cosine theta, r times sine of theta. And that's my point, x comma y. So in general, if x comma y is on a circle of radius r about the origin at an angle of measure theta radians, then we have x equals r times cosine of theta, and y equals r times sine of theta. We're going to use this idea again and again, so let's put it in a nice blue box here. And there's something else I can do with this, because if I know the radius of my circle and I know the coordinates, then I can actually figure out the cosine and sine of my angle by solving these equations. So the cosine of theta is going to be x divided by r. I'm just dividing both sides of that equation by r. And the sine of theta is going to be y over r. So if I give you a circle and I tell you there's some point over here, now I'm going to draw a different angle. And let's call that angle measure alpha. Okay. And then I say, let's say this point is, now I'm just giving an example here. Let's say it's negative 13 comma negative 12. Okay. And I ask, what are the cosine of that angle and the sine of that angle? Let me move down a little bit so we have some room to work. Well, the first thing that I would do is I would figure out what is the radius of the circle. And to find the radius, I would need to use the Pythagorean theorem, because I know that I have this little triangle here, and the side lengths of that triangle are 13 and 12. So the radius squared would have to be 13 squared plus 12 squared. So r would be the square root of all of that, which is, let's use our calculator here, square root of 13 squared plus 12 squared. That comes out to 17.7. So that would mean that the cosine of alpha would be equal to my x-coordinate, which is negative 13 over 17.7, and my sine of alpha would be the y-coordinate over the radius, so negative 12 over 17.7. Let's calculate those. We get negative 0.73 for the cosine, and then for the sine I would get negative 12 over 17.7. That comes out to negative 0.68. Seems about right. Alright, so the purpose of this video was to show what the sine and cosine mean and what they look like when I'm dealing with a circle of radius other than 1. So a circle of radius r, where r can be any positive real number. Alright, in a future video I'm going to talk about how we find the sines and cosines of a few certain special angles that it's useful to know the sines and cosines of. So stay